All right, advent of code day 18. Day 16 was rough. Day 17, I still need to do part 2. We finally reached fresh air. We've emerged near the base of the large volcano, actively erupting, something about obsidian. We scanned it, low resolution scan, 1 by 1 by 1 cubes on a 3D grid. It looks like we're supposed to care about the surface area, so 2 adjacent cubes, 1, 1, 1, and 2, 1, 1. Each cube would have a single side covered and 5 sides exposed, because cubes have 6 sides, so surface area is 10. Here's what I assume is our input. In the above example, after counting up all the sides that aren't connected to another cube, the total surface area is 64. What is the surface area of your scanned lava droplet? So we got this input. This places cubes in different spots. We basically need to check each of the neighbors to see if they're connected for each cube and then count which sides are open. I feel like this would be potentially really good for a matrix. So we could do n-dimensional arrays. I think there's some kind of neighbors function in here. I don't work with these matrices too often, so I would have to look it up. My guess is similar to the other days. Part 2 is going to be, hey, do this at scale. So I think we'll start off with the simple approach, the non-matrix approach, and then maybe I'll refactor it into doing like a 3 by 3 matrix or something. So let's start with these. One thing that might be interesting is using these as vec3s. So there is this crate that like Bevy uses, for example, that has vec3 as a type in it. They all do F32s. Oh, here we go. We do have uvex. Uvec3 would probably be what we want. Maybe ivec3 in case we have to go negative. So an ivec3 gives us access to a couple of interesting things. Like we can do .x and .y, which will make the code that we write a little bit more understandable. So I think I'm going to do that. And we can do a vector from an array. So I think I'm going to cargo add glam. There's a bunch of things that we might want to do in here, features that we could enable at some point, but we're just going to start testing again. We've got part 2 ignored, part 1 failing. So we almost don't need to do a separate non-parser here. We could almost do it just like let underscore points equals separated list 1, line ending, tuple. What did I say I was going to use? Did I say I was going to use the i32 version? Interesting that there's no i64 version. So hopefully they just won't get that big. There's also some matrix types and whatever, but I think we only care about the vec. So we could do very specific tuple here, or we could do separated list 1 again, a tag of comma, and a complete i32 for the parser with the input. Then we would unwrap that. So we end up with the points is this separated list. Points is going to be a vec of vecs, but I do want to map this, and I'm going to do an R here. Well, actually, I think we can do X, Y, Z, and then anything else we don't care about. Then we want to grab glam vec3 and pattern cannot match with input type vec i32. I thought we were able to do that. Maybe we have to do it as a slice. So because the vec comes in as an owned type, we just get vec here, and it's not a big deal. We can do vec0, vec1, vec2. To match on this, we would have had to turn it into a slice. Oh, we also want ivec3 here. We don't want a regular vec3. So I'm just going to map over this. I'm going to take vec and I'm going to do vec 0, 1, 2 because it doesn't really matter to me. We could also do a tuple here for the parser and then get 3 destructurable values out of it if we wanted to be more specific. We know this input is always going to be good, so we don't really need to care about it. But you can pattern match like I wanted to do off of a slice. You just can't do it off of a owned vec without turning it into a slice. So in this case, we get a vec of ivec3s. I'm going to add this to do to the end. Line ending is something that we haven't brought in yet, it looks like. Yes, we have. What's the problem with line ending? Cannot infer the type because the type annotations for points has to be specific. Oh, this has to be a vec of ivec3s, which still doesn't give us line ending. Type annotations needed because separated list 1 with a separated list 1 inside of it. The line ending where input is a string slice. Oh, it can't infer the error. Okay, that makes sense. I should have read the error message. Cannot infer type of the parameter e declared on the function line ending. E, I happen to know, is the generic error type for non-parsers. The reason we haven't seen this before is because usually we are returning that iResult type. So if we did something like this, right? We did iResult like this, we would need to, did we not bring in iResult? I made the mistake of making that a tuple, which it is not. So iResult string slice vec of I3s, and then this would have to be okay. So we could destructure like this if we wanted to. Of course, that does mean we need to have an else here if we do that. So we could throw a panic in here. So instead of doing a dot unwrap, because noms parsers are pretty generic for good reason, we do have to specify what the error type would be if there was an error. So we do the iResult type here, and then we destructure using let. So let, okay, and then the tuple that we're used to seeing for the parser, which gives us this points inside of it. And then we have else here. So this whole thing looks a little convoluted. I would probably pull this out into a separate function, and then this is defined on that function's return type, which means that we don't need to define it here. But this is what it would look like if you just wrote the parser like inline. So here we have the function signature for points as it would be, and we can grab separated list one here with the input and drop it in there verbatim. And then we get rid of basically all of this. We do equals points input, and then we get to unwrap here. So personal preference. I think that this is a little bit more testable, reusable, whatever you want to say about that. I think that this is more the way I would write it in general, but you can write it in line like I just showed. So we get points here. So if we debug points, we get a bunch of IVECs, and then our task is to match every IVEC with anything that it's next to. So I think we get that by just checking for +1, -1 on every axis. So really, because we're doing just direct access more often, and the alternative would be a find on a vec, I would probably want this to be a B-tree map. Imagine that, Chris using another B-tree map. In this case in particular, if we do a B-tree set, we can get each of them. So if we go to the docs, we can see the from implementation. Here, in this case, we have a from array with some const generics. We also have from iter, so it's pretty easy for us to do something like this. The interesting part here is that ord is not implemented for IVEC3, which is totally fine. We can move to a hash set. So if we do hash set here, we can do into iter to clean up any issues. So in this case, iter will give us references to the points. In this case, we are not going to use points again, so we can reset it to be this hash set and use into iter to take ownership. So we get IVEC3s instead of this. So this would also work though if we wanted to. So we could do a reference to IVEC3s. I just don't think we're going to use that vec again, so I'm going to take ownership of it, and we're shadowing the variable name anyway. So we need to iterate over each of the points, and we're going to need to map, and then I think we sum at the end. So we're going to map into number of free sides, and then we're going to sum into, I don't know, a U64, because that seems like the pattern in Advent of Code. I guess this is called surface area in the problem, right? Surface area equals this. And now we need to take point and do all of the individuals. So if we go to the IVEC3 docs, we see that it does have fields X, Y, and Z. So if we want to, we can do IVEC3 X, Y, Z for a destructure, and that will let us do X -1, Y, Z. And we basically need to do this over and over for each of the values. So there's Y -1, Y +1, Z +1, Z -1. And this is all the values that we need. And I'm going to use filter map here because we're going to get the IVEC, and we're going to take that IVEC and we're going to do points.get with the IVEC that we're given, which, because we use filter map, points.get will return an option type, which goes straight into filter map and we'll filter it out. And then we need to count the results of that, and then we can sum it. And what are our issues here? Sum usize is not implemented for U64. That's fine. We can change this to a usize. I don't really care. Is my construction wrong here? I think this is going to be wrong because of references. So if we destructure the reference in the map, then we get the actual value, and then we don't have to do a bunch of dereferences here because I'll show you the types here. We get I32s with the reference destructure. If we don't have the reference destructure, we get references for all those numbers. So one character instead of, 2 or 3 for each row or something like that. I don't know if I did this filter correctly. Do we want points.get if that exists to be true? I think we want points.get to be false. So we're going to do the opposite, and we're going to leave this as filter. So we're filtering for all the none values, which means that the point doesn't exist for that cube. Then you do surface area.toString, and we get far too few because I didn't put the right value in. So if we look at this, 64 is the right number. So we got this correct. And we do need to grab our puzzle input. Our puzzle input has significantly more numbers. So I assume that that's the challenge here, 2,000 numbers. So our test is passing, and cargo run bin part 1, 3,564. So not a huge deal as long as this is correct. It is. So we got a gold star. Part 2. So what we did here is we got all the points as IVEX. We did that by doing a parser for separated list on the line endings, separated list commas, which gave us a vec of 3 numbers. We could have done a tuple here and gotten X, Y, and Z instead of doing vec 0, 1, 2 for this map. We turned it into IVEX because I like the idea of being able to destructure X, Y, and Z here instead of destructuring like 0, 1, 2 or something like that. We turned that into a hash set because it's easier to run points.get on a hash set than it is to do vec.find. So setting up our data structures early for the access patterns that we're going to use later. Then we take all the points and we iterate over each of them. We destructure into XYZ. We destructure the shared reference off so that these are actual numbers. We turn each of those into one of the vecs that could be on each of the sides for X, Y, and Z. Put those into an array, iterate over it, filter for any of them that are not in the B tree set, and then we count. We sum up that iterator because we've mapped this into the count of sides that are open, and then that gives us a surface area. So the cooling rate depends on the surface area. Your calculation also included the surface area of air pockets trapped in the lava droplet. Instead, consider only cube size that could be reached by the water and steam as the lava droplets tumble into this pond. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. In the larger example above, exactly 1 cube of air is trapped within the lava droplet at 225. So the exterior surface area of the lava droplet is 58. What is the exterior surface area of your scanned lava droplet? So let's look for 58 here, and let's grab our test and start it running. We can pull the logic that we just wrote in and copy it into part 2. And we basically need to remove a number of air pockets, right? So if there's 1 air pocket inside, that means that we do -6 on the interiors. So we basically have voxels here, but I haven't done a lot of work with voxels. So I wonder how we get a bounding box, basically. We basically need to determine how many cubes are on the interior while also calculating the different ways in which it can result in space interior. So if we had a 3x3 cube that was space, the middle cube wouldn't affect the surface area at all. So we need to determine whether we're on the inside or the outside for any surface. And I wonder if this is guaranteed to be in any particular structure or if this is just like random. So for example, this could be like a 3D structure that just like does circles going outward or something like that. In which case, if we did something like looked at one of those inner circles to the left and saw if there was blocks there, then it would be one thing or the other thing. What could we do? We have all the points that are blocks. It's calling it a droplet and not like a wisp or something. The other thing is like, what if this whole thing was just a column of cubes, right? Is that a possible representation for this problem? Because that would be the surface area for all the cubes because there's no inside. I feel like I want to take 2D slices of the cube. So take like the slice on the XY axis, for example, and then we could do some like 2D scan basically on layers, which could theoretically allow us to get around another issue. Would make our math simpler anyway. So for example, there are a bunch of Minecraft tools out there, right? If we make this much smaller so that it's a little bit more kind of understandable, we could take one axis, right? And then the problem becomes we have this one side that we've hit, the yellow side, and we have to determine if there's anything on the space sides. So if this position right here happened to be 0, 0, 0, and this direction was negative, is there anything on the negative X direction from that or the negative Y direction from that? And then we ignore the Z direction, or rather, do we ignore the Z direction? Because we can basically do this as we go down, right? And then we have this, and there's a gap here. So we know that all of the interiors have a block on the other side. But this approach only works if we actually have a sphere-like shape. Because if we had a column with another gap in it going up through this, for example, then we would have not only this exterior circle, but we would have an exterior inner circle. So there would be on the outsides of this, we would have exterior space. The interior would be interior space, right? Inside of the sphere, between the sphere and the column. And then inside of that column would be exterior space again. So if there is what I'll call exotic geometry, then I think we need a different approach. The test input only gives us one. I don't know if there's something we can use to visualize this a little bit better. Well, I mean, there is. We could like write a script in Bevy and visualize it, but looking for something that's a little bit more ready-made. I think we take the simple approach first and then see if that works. So for example, the block 322. This is XYZ, so we're on the Y2, Z2 plane. So if we say Z is, I don't know, positive towards us or something, and Y is vertical, then X is horizontal. So X is a regular number line. We're at 3, 2 up, 2 towards us, at which point we have to figure out if there's anything to the right of 3 on 2, 2. There's 3, 2, 5. So maybe we try a different approach. Maybe we try to determine if the connected points don't exist. So if it's like 2, 2, 2 or whatever, and there's a side that doesn't have a block on it, we check that block to see if there's anything in any direction from it. And if it hits something on all sides, then it's interior. And then we only need to check against all of the other blocks. And if it's interior, then we count it, or we don't count it, I guess. So we got a count here, right? We've got an IVEC here that represents a point that doesn't have a block that borders the current point that we're looking at. And if that block is an interior block, so if it's interior, then we do what, 1, 0, otherwise 0, 0, 1. And we use this as left-hand side is exterior walls and right-hand side is interior walls. So now we just need to write this is interior block function for some point and a reference to all of the points, I think. So if I can use Rust Analyzer to generate this function, it automatically generates with the arguments that we passed in, which is a IVEC and some points. I think the IVEC can be a reference as well. We don't actually need this for anything. Like we don't need to have ownership of it or anything. So this is an IVEC 3 and we have XYZ. We have all the other points and we need to basically have a block in some direction for each of the points. So we basically need the same thing we did above, right? So we could do this manually. So bounded X positive. So if we do points dot iter dot find, and this gives us some point, and for it to match, it needs to be point.y equals y and point.x or z equals z. And our big thing is that point.x is greater than x, right? So we've got expected I32 found reference. So we could destructure this too, if that's required. So bounded X position, we iterate over points. There's going to be a lot of iterations, but I think that's okay. We find a point that is greater in the X direction and equal in the Y and Z directions. And because of the way that we're iterating over these, we know that there was a gap. So this is dot is sum, right? So we need to do this in both directions, greater than and less than, for all 3 points. So instead of trying to do anything fancy, I think I'm just gonna rewrite all of this. So we have these now, and then we have 2 more of them, and this is X's, and this is gonna be Y. These have to be equal. This has to be greater. This is going to be Y. These have to be equal. This is going to be less than. Am I doing that in the right direction? Yes, I think I am. And then this is going to be Z. So these are going to be equal and greater than, and this is going to be a Z, and this is going to be equal, and this is going to be less than. And that technically gives us whether it's bounded or not. So whether it has blocks on all sides. So if we do this, iter.all, and they're already Booleans, and we'll dereference that. So this, if we have something that is bounded on all sides in all directions, then we have an interior point. It doesn't matter where those points are. It doesn't matter where those blocks are, as long as it's bounded on all 6 sides, because we're testing all air blocks. So that's what this is. So is interior block gives us left-hand side. Otherwise we get right-hand side, and we don't want to count here. I think we just want to count exterior blocks. The types here are wrong, of course. Interestingly, we still get 64 for our answer, but we need 58. I didn't accidentally call part 1, right? Okay, cool. I've made that mistake before where I call part 1 in the part 2 test. So let's see if any of these register as interior. We should get exactly 1 interior. 1, 2, 3, 4, 5, 6. We should get 6 interiors on that. My mistake. We get 6 interiors. Oh, you know what? It's not supposed to be count because this is going to be 0. It's supposed to be sum. That's the issue. And then hopefully we get 58 from that sum, which we do. So hopefully that this algorithm that we've written here will work on a much larger input. So 2101, if our algorithm is correct, it passed the tests. So I'm hopeful, and it's not. The answer is too low. So it must not be like a sphere. It must be visually something else. There must be other. Let me check which number we're supposed to be returning. Back into 18. What is the exterior surface area of your scanned lava droplet? So it's really unfortunate that they gave us a single, very simple test case and not something representative of the input. Because now we have to kind of figure out what could possibly be going wrong. I think our calculation is accurate, but the problem is probably that it doesn't look like a cube. So what if we do something super silly to take a look at it? So visualize.rs and cargo add bevy. And I think that the easiest thing for us is going to be grabbing an example from the bevy repo. So I grabbed the shader example because I am fairly certain, well, if I want to do anything with the custom materials, it's there for us to do. If we want to do something like a wireframe, that would be cool. We have a size 1 cube, in this case that we're spawning at 0, 0, or 0.50, and then a camera 3D bundle. This has a branding icon. So I think I'm going to get rid of that color texture. We could probably just do a color material here, honestly. But the thing is, I want to be able to take the code that we just wrote and visualize it. So inside of the shader material stuff, the example that we just pulled out is this shaders custom material WGSL file. So we can go into assets, shaders, I think it's custom material.wgsl, and I'll copy this, and it's assets at the root. So we'll do it out here, and I'm going to name this voxel.wgsl. I'm getting a warning that my WGSL analyzer version is out of date. I don't think we want the texture sampler. We just want the color. So I'm not too worried about this. It's just going to be material.color for now, which is going to be a vec4. Visualize.rs. Custom material needs to have this image chopped off it because we aren't using it. The alpha mode is just kind of like something that is there that we don't really care about, but I'm going to leave it. And then I think that's good. So let's do a cargo run bin bevy. Visualize is what I called it, of course. I bet you that that's the wrong way to spell visualize, just thinking about it in my head. So we run into error while reading an asset because I didn't rename the import path, because this is now voxel, even though it isn't really, it's just, you know. Okay, so there's a cube, right? Actually, probably. The colors would have made more sense. The vertex output here for the WGSL file is defined in one WGSL file. These are defined all over the bevy stuff. This isn't really a bevy tutorial today. I'm just kind of like using it. So I'm not really going to explain everything that I'm doing. But I want the world normal, I think. World normal is a vec3, but we need a vec4. So vec4 1.0 for the alpha always going to be something. So now we see this, right? And that's fine. It at least gives us a square. And I need the input to pull in, right? So let's grab the points parser. Well, actually, I don't think we need to grab the points parser. We can make this pub because this is a lib. And we can do day 18 points. And we do a read to string here, but I think I'm going to do include bytes over here, or include string anyway. So in visualize, I'm going to do let input equals include stir, which is a macro that is going to be coming from the root. So we need to do something like this to go up 2 bins or 2 folders from visualize into the root to get input.txt. And then we do let points equals points input unwrap, which gives us the string slice vec of i3s. We don't care about the input. We only care about the vec of i3s. And then for point and points, we're going to spawn in one of these cubes. I'm going to do XYZ like that, and I'm going to destructure XYZ from here. which is going to complain because did I forget the format? Yes, those need to be F32s, which is totally fine by us for the purposes of rendering. Not for the purposes of calculating, but for the purposes of rendering. And we end up with a need to make our camera act differently. So there's this stuff in the Bevy examples repo that I often talk about. One of these is in libs. I think basic camera is what we want. Source lib. And I'm just going to copy this in because I don't really care about it being do camera.rs, paste all this in, Bevy input mouse, whatever. We do need to bring, I don't think we need to bring any dependencies in actually. I think we're good. This code is originally from Griffin, if you're familiar with them and their Bevy work. It's been super useful for the Bevy examples at least. Just gives a really like basic camera that you can pan around with. I just need to find the usage of it. I know the usage was in that comment, but don't particularly love the new search functionality on GitHub. I think Point Cloud uses it. Yeah, so we need to pull this into visualize. And then we do have another option too. I could have done a Bevy eGUI like inspector thing, which would have also been fun. But I kind of just want to scroll the camera and I know that I have this already. So this goes into the camera, wherever we spawn our camera. Here we go. In camera, commands.spawn now takes a tuple as of Bevy 0.9, which is dope. This comes from day 18 camera, which we aren't, fine, we can merge the imports, it doesn't matter. But we need it in lib. So we do pub mod camera and now visualize can use the camera and then we run. And these are single digits. So I'm expecting it to show up at some point, but I'm not seeing anything, which is unfortunate. Let's do like -20, right? What's our 412? I think 20s will work. So -20 on Z. X is probably 0, maybe 10. And then we start to see that over there. So we do have a light in here. So we can kind of see what's going on. It's not the greatest, but I bet you if we get in here, yeah, I think like something in there like that where my cursor is would be almost problematic if it existed and there was another cube over here. I'm just trying to look and visually find a place where our algorithm isn't going to work, which would probably require us to be kind of inside the cube like this. So something over here like that maybe. Ooh, that's it right there. That gap, I think that would do it. Although it said it was too low, right? So if it's too low, that means we're not counting enough exterior spaces. So we do need to be out here, first of all, and it needs to be, oh, this needs to pivot on the center of this orb for this to really work well. Let's do orbit focus at 1010 instead. Of course, these need to be F32s if I can type correctly. So at least a little closer to something. What looks like, I feel like there has to be something that goes in. It does look fairly circular though, from everything that I'm seeing. So I'm not seeing like the thing that I would have considered to be like a problem. So what then? We've filtered out all of the solid sides by the time we work on this, right? Oh, you know what we didn't do actually? Now that I start looking into this. This is connected on one side, right? So we have the IVEC for each of these positions, but we don't know which one we're dealing with. So we don't know what the original block is. So I think we do zip XYZ, and this is std iter repeat. So we just repeat this tuple over and over. This needs to be down one. It needs to be with the iterator, not with the vec. So at this point, what we have is original and the new IVEC. And then we have the original and the new IVEC. And the original needs to be canceled out, right? Because it will be on one side connected. Is that true? So if it's an interior block, there is an original block that is connected to it. And all we're doing is checking to see if it has a block on every side. So that block will actually come back positive. So it'll be is sum. So in what cases it's not going to work? We only iterate through filled blocks. We only check the blank spaces on the outside or inside connected to filled blocks. If it's the outside, the only place I could see it failing is if it's in a gap that is capped by a 1 block away block. So it would have to be like in here with a block like 2 Z index towards the camera. It's tough to see stuff on this side, isn't it? I just realized that for this voxel, I need to absolute value this or something. I don't actually know if that works on Vec3s, but yeah, I mean, we need to see the extra sides. So we need a little bit of that. So the only one that I could see this being an issue for maybe, anything in here, would that work? No, it's anything at this point. I'm basically just trying to find a block on the outside that counts as interior due to this algorithm. And the algorithm is we have to have a block on every side, no matter how far it is away. So it's always true for interior blocks, right? And I could see how it could theoretically be true for an exterior block, but I cannot find an actual location for which that is true. Like if there was a block under this, I think it would count, but that looks like it's filled in. The other problem is it's a block type that would be very hard to see from the outside if it did exist, right? I think that might be it right there. Whatever block that is, I should have I should have added in some click to debug kind of functionality here. I think that's it, because I think there's a block here, block down, block over. That places it under this bridge, and that bridge is blocked in on this side, as far as I can tell, and blocked in on that side. So maybe we have to do it for 2 of them. So like do the one that's next to it and the one that's next to that. I wonder how many of those we get away with though. Do we need to do it twice? So if we do the bound here and then we detect again next to it and see if that air block potentially is also interior, I wonder how many times we have to do that for that to work, if that's the issue. So we've got the interior block here, right? And we've got a set of blocks that we've found that are some distance away, right? So the Manhattan distance for these blocks, if it is greater than 1, right? So if it's 2 blocks away, then there's the potential for the air blocks in between to be exterior air blocks. And technically at that point, it's just, can we find a path from the air block that we're at to a exterior air block? So we have to do this in every direction, which would be nice if I didn't write it like this. So we could basically take the same calculation we're doing here, right? Each of the X lows and whatevers. We iterate over them. We filter for any that are none. And then we do the is interior block again. So I think this function needs to be abstracted so we can reuse it. The original doesn't matter, so I'm going to get rid of this zip because we don't need to do the extra processing, which means that we have this function abstracted out to here. So what do we call this? We call this process block because I don't know anything better to call it at the moment. That returns a U size. So this is going to take an IVEC3. It needs access to points as well, which is what, a hash set. So that would work. Let's make sure that points is what we think it is. Points is a hash set of IVEC3s. That is correct. So if we run process block here, then we get what we expect. If we run process block for each of these, right? So basically is interior block for this, right? We could do this again, right? So if is interior block, then we need to test if it's really an interior block, because exterior blocks are guaranteed. They're exposed to air, but interior blocks need to be processed again. If it is really interior block, let that equal process block, whatever, then this, else it's exterior. So we need to process block, right? But this loops it too, which is really unfortunate. I don't want to infinitely loop this. So I think I just want to copy and paste the logic in. I think calling the process block here and then leaving this logic here is fine. So is really interior block equals process block equals 0, right? Because it returns the exterior number, map exterior. If exterior is anything, then it's an exterior block. So we need to process each of these in turn, all of them, for the new vec. So we can do this again, right? So if we destructure XYZ, we get to copy paste that code. We get each of these blocks. Then we get to iterate over those blocks, find any of them for which an exterior exists, right? Process block takes the IVEC and points. So it takes block and points. And if any of them, I think this is going to be is really exterior block, right? If any of them are whatever. So we'll flip this. So we'll flip the tuple 0, 1, 1, 0. And then we will run the test, which should run slower because we're doing a lot more calculation. Did I write all that into part 1? No, it's in part 2. Part 2 is still 64. Didn't part 2 pass before? So we need to filter out here. We need to filter for any of them that are none, because those are the air blocks, right? Expected expression found dot in camera controller. Is there a test in camera controller? I don't think so. Camera.rs line 10. Oh, this is, this counts as a test. Oops. Let's just make that not. So part 2 is now still passing. So this only calculates for 2101. That's the same number we got, right? So I added logic that does nothing, right? Not the right answer, too low. So I literally added a bunch of code that did nothing. Okay. If is interior block, then we need the interior block. We need to do the X's. So everything that connects to this interior block. We're looking for an air block. So we filter for something that is none. If any of them have an exterior value of greater than or equal to 1. There we go, 2106. That's a bigger number. 2106. Submit. That's a gold star. Okay, cool. That was the answer. So let's reward ourselves with a little bit more ASCII art. Here's the full ASCII all the way in through the bridge, the waterfall. Now we're at the base of the volcano. Sweet. So this is really messy. It's not really the way that I would like to leave it, but I'm going to leave it like this because it's advent of code. And really the only goal is to make this work. I have to believe that there's a better way to write this, and probably a better algorithm to use, to be honest. But overall, what we did for part 2 was we did the same calculation as for part 1, where we did is interior block for any of the blocks. The is interior block looks out in all 6 directions to see if it can find another block. The part that breaks down for is if you have an air block that is, say, surrounded on 5 sides to make it easy. And then the 6th side is 2 blocks away. And the air block that's right next to the air block that's contained in the other 5 blocks is actually an exterior air block. So what our original algorithm didn't account for is basically tunnels that output to the external side, because those are counted as external. So luckily in our input, we only had to calculate that for one path, but we could generalize this into, I think, any or a number of different paths, and we could limit that path somehow. So that's all we're doing here. If we have an air block or something we think is an air block, we're going one more path down in any direction for any other air block and checking to see if it's connected to anything that is external. So this only works for a short path for us, but it does work. So that's it. Hope you had a great time with day 18, and I will see you in the next video. Have a great day.